All right, so in this video, I'm talking about copy constructors in C++. So to explain the concept of copy constructors, let's have a class called vector. And in the private members of this class, I have an integer pointer called vec and a size. And in the constructor, I basically initialize the size in the default value is 10. And then I create an array dynamically on the heap and make vec point to that array, particularly to the first element of that array. And because this is a dynamic memory that is allocated on the heap, we're supposed to be cleaning it up. That's why we provide a destructor that is going to delete that memory when we go, for example, out of scope. Okay, so it's a pretty simple class. And what we're trying to do next is create an object of this class A using this constructor, right? And then we're trying to create another object B off of A. So we have an existing object A and we're creating B off of A. So this is how we say this in C++. Or we basically initialize the object at the time of declaration. We initialize it with A. So both of these are going to be copy construction. And what happens in C++ by default is something that we call shallow copying. So when we first create the first object, A, so this is what happens in memory. Size is initialized to 5, and an array is created on the heap, and the address of the first element is assigned to vec. So vec now points to the first element of the array. Now, when we try to create an object B off of an existing object A member-wise copy happens. So the 5 is copied here, and the 300, which is just a random number that I came up with, is copied here. And there are actually two problems with this. Problem number one is that these objects are not independent. They basically share the same memory, right? And problem number two is that when object A goes, let's say, out of scope and invokes the destructor, it is going to free this memory. And when object B again goes out of scope and calls the destructor, it is going to attempt to free the same memory. And that's going to create basically a double free problem. And it's going to cause our program to crash. Now let's see this in action. So let me just go ahead and compile this code. So g++ main.cpp-o main. Let's just run this code. And as you can see, we have the program crashes and it says pointer being freed was not allocated. Well, it was allocated, but freed before, freed for the second time. So this is the default behavior. So obviously the default behavior doesn't work when we have some dynamic memory involved. What we desire to have, the desired behavior, is called deep copying. And with deep copying, we would like to create a separate memory for object B, separate array for object B, and then copy these like stack-based variables first. And then, like I said, create the separate memory for object B. So that's number one. Whatever, stack-based variables, we need to copy them first. And then we're going to be creating this separate memory for object B. And then what we're going to do next is copy or iterate over the array of object A and copy the elements here. So now we have complete copies that are basically independent. Okay, and each one of these objects has its own memory. So how do we achieve this? To achieve these three steps, so this is step number 3. To do this, we need to define our own copy constructor. And the way we do this is basically by creating this copy constructor. Remember, it's a constructor, so it's going to have the same name as the class. And it accepts a constant vector reference, and we're going to call this other, right? And we're going to do these exact 3 steps in the copy constructor. So we're going to first copy the size. So this arrow size equal the other object dot size. And then we're going to create a separate memory. That's step number 2, separate memory for the object that we're trying to create now. So this arrow vec equal new integer of this arrow size. Okay. And now the third step that we're trying to do is basically iterate over this array, copy the elements into this array. Okay. So that's basically a loop for integer I equals 0, as long as I is less than the size, plus plus I, and in this loop we're going to make this arrow vec of I equals to other dot vec of I. Okay. So now let's just write a quick cout statement here to verify that this constructor is being called. So let's go ahead and include IO stream. And then here we're going to just say something like std : cout copy constructor. Okay. Copy constructor. Okay. And let's just have a new line here. Okay. And let's just go ahead and save this, compile again. And now let's run our code again. Well, as you can see, the code doesn't crash and the copy constructor was actually invoked. Now let's have few notes here. Note number 1 is that we're having const here. Well, if I remove const, the code is still going to compile, no problems. However, it's a good programming practice to have because we're not changing the other objects in this constructor, right? So it's just a good programming practice to have. The other issue is that we're passing the other object by reference, and that's important because if I make it call by value, what happens here is that when we do call by value, that actually involves a copy. So normally when we call a function by value, parameters are being copied. But at the same time, we're trying to define how these, the parameter is just a vector object. So we're trying to define how this object is supposed to be copied, right? So we cannot make a copy while we're defining how this object is supposed to be copied. That's why this is supposed to be called by reference. So if I make it call by value and I try to compile, this is actually going to throw an error. So that needs to be called by value. And this is just a good programming practice. So this is the first note. The second note is that this is again is just a regular object. It's not a pointer. That's why we use the dot operator to access the members of this object. We don't use the arrow operator like we do here. Okay. So that's a second note. A third note is that we're able to access the private members of the other object. So how is that possible? This is possible because the access specifiers here, private or public, are basically or operate at the class level, not at the particular object level. Right, so if we're in a given object here and we're trying to access the private variables of the other object of the same type, we can do that, right? We generally cannot access the private members from an outside world, right, of an object. But we're here, both of the are basically of the same type, so we can do that. We can access the private members. Okay, so that's it for the for the copy constructors. And I hope you find this video useful. See you in another video. Bye.